Okay, looks like we're about ready to begin. Okay, yeah, not used to standing up here, usually on the other side. So before we begin, I want to give a tremendous thank you to Morty and the entire Quality Bath team. Finally sitting over here, being involved in the meetup. You see a little bit what goes on behind the scenes, how much time and effort they put in. This doesn't just happen all by itself, setting up all the equipment, getting all the food, making all this possible. And being here for a couple of years, coming to these meetups, I've gained a tremendous amount. So thank you all for that. So before I begin, I just want to, see a little bit in the crowd, how many people over here have heard of and actually used AWS Lambda? Wow, okay. And let's just ask the same question for GraphQL. How many people heard of and actually used GraphQL? Okay. So I hope, at least by the end of this speech, all of you will be as excited about serverless and GraphQL as I am. So about a year ago, Tzvi was sitting right here, recently moved into my neighborhood. And we met each other, and Tzvi wanted to take his IT experience and get a little bit more involved in programming. I wanted to take the little bit I knew about programming and get a little bit more involved and take it to the next level. So we decided to embark on a project and build a site where it makes it really simple for anybody to come and post a deal or products and be able to earn affiliate commissions without getting involved in any of the complex application process. So we ended up building a site, and we ended up doing a lot of interesting things from a technology perspective. But two of the most interesting things that we actually did is GraphQL and Serverless, and that's what we want to share with you tonight. So what is Serverless? So when people hear Serverless, everyone's like, there are really no servers involved, and people write big blog post articles on it. But the best I saw was summarized in Serverless doesn't mean that servers are no longer involved. It simply means that developers no longer have to think that much about them. So that's very powerful and just really explains what serverless is. I'm going to try running through the slide deck a little bit quickly because these are two tremendous topics that we're going to be talking about serverless and GraphQL, and there's a lot of stuff to cover, and nobody wants to be here for all that long, so we're going to try to cram all this in. So in general, when the word serverless is used, it can refer to two things. It can refer to serverless-driven backends, serverless-driven architectures using backend and services, and can refer to FAS, which is functions as a service. So serverless-driven architecture is where you build an application and you don't write a single line of backend code. So in this example over here, we built an entire application where we're using Auth0 as our authentication service, Firebase as our database service, Algolia as our search service, and Stripe as our payment service. And you can really build some really powerful applications without writing a single line of backend code. And that's a really interesting topic, but that's not what tonight's talk is about. Tonight's talk is about functions as a service. This is where either you have an existing backend or you know you need to write your own backend code. Instead of writing your code and typically deploying it on a regular server or maybe using Docker and spinning up containers, you're just going to write a function. You're going to hand it off to some provider that's going to take that function, and they're going to worry about executing the code. So you would say, I want to write a piece of code in JavaScript and running on this node version, give it off to the provider, and they take care of everything else. They give you methods to invoke that function, but you don't have to worry about anything else. So in general, AWS has been early on created Lambda. I don't remember the exact year, but it's been a while, and they started with functions as a service. And then Google got into it, Microsoft, IBM. We played around probably about 8 months ago with some of the other, with Azure and Google, and it was night and day. AWS is way ahead. So tonight's talk is going to be about serverless on AWS. So when we talk about serverless on AWS, there's really two services that AWS offers, or primarily one service, which is called Lambda, and that's actually the functions as a service where you would write your code, pass it off to AWS, Lambda, they'll take care of the entire execution, and that's functions as a service on Amazon. But we're going to mention API Gateway because API Gateway really unleashes the true power of Lambda. API Gateway is a simple service that allows you to create RESTful APIs by just specifying what your routes are going to be, and it automatically can take your request and proxy it to Lambda for you. And now you could actually start building APIs on AWS. So why serverless? Okay, great. We know how to spin up Docker containers. Life is great. Serverless is really, really cheap. So for starters, out of the box, you get 1 million executions free. Beyond that, you're paying 20 cents for 1 million invocations thereafter. They bill you based on the amount of memory you're using and how long your Lambda function runs for, and they bill you in 100 milliseconds time. So you pay per use. There's no fees while it's not running. You're never going to pay again for the old dev server that you put up 6 months ago, and then you look back at your bill, you're like, oh gosh, I just wasted $100. Or that one server that everyone knows is up, that service, and you're asking old developers, you might need it, or might use this, and no one knows if you can use it or take it down, and no one knows what it is. You're never going to run into that again, because if it's not being used, you're not paying for it. So just actually, we put our website up probably about 6 months ago. We've yet to pay a penny for computations on Amazon. So it's awesome for your development projects, but even for enterprise projects, it's great. So here's a company. It's called Postlight. They had a text parsing readability API, and they were doing 40 million API requests a month. Their service was costing them $10,000 a month. They moved over to using API Gateway and Lambda, and it dropped to $370. So as you can see, your savings are by an order of magnitude. So scale. So you'll never have to worry about getting more servers. So in general, when we talk about auto scaling, so these are like the hot words: auto scaling and infinite scaling. Everybody wants don't worry about it. So that's not really the case. No matter how big you get, the bigger you get, the more you have to worry about it. So AWS they'll let you have 3,000 concurrent executions running at a shot in your Lambdas. So at first, that sounds like, oh, that's not so much, 3,000. Actually, really depends on the region. Certain regions only allow 500, but the US East one allows for 3,000. So we're looking at it, we're like, hey, that's not so much. So AWS tells you how to calculate, to actually make a calculation to figure out if it would be enough for you or not. So if we were running an API, an average API call was executed for 250 milliseconds. Now again, this is on the server, not when you're on a client and taking into account the network times. So 250 milliseconds, plenty of time for your code to execute. That would equal 4 API calls equal 1 concurrent execution. That would equal 12,000 executions a second, 720,000 executions a minute, and 43 million executions per hour. If there's anybody here that's working on such an application, I'd love to talk to you about it. Agility. So you can spend a lot less time in DevOps. No need to configure or maintain patching servers. You never have to worry about if all of a sudden you're going to have a spike in traffic. You're going to write functions, not config files. So let's look at over here a simple example of a Lambda function. So this is a really simple Lambda where you're exporting a handler. It's a function that takes an event, a context, and a callback. You run your code. When you finish running your code, you call the callback. In this case, we're passing back hello from Lambda. The event is whatever's actually triggering the Lambda, and that would give you access to if your Lambda was being triggered by an API gateway call. You would have access to the headers. If it was a post request, you have access to the body. That's how you would actually access the data that's being passed into the call. Context is stuff specific to the running environment of that Lambda function. We'll see a little bit later some examples of both of these, and then you trigger your callback, and that's how you send your data back out of your Lambda function. So with Lambda, you write your function, you zip it up, you upload it to Lambda. AWS takes your code, they store it on S3, which for whoever doesn't know, that's basically regular cloud storage. When it's invoked, they reach out to S3, grab that code, spin up a container, execute your code, and then send you back that data. After 5 to 15 minutes of no invocations, the instance of Lambda is destroyed. Now, what's amazing is that Amazon's able to do this really, really quickly. They're able to make all this happen in usually around 2 to 3 seconds. But typically, if you're developing an API, that's not going to be 2 to 3 seconds is way too long. So we'll see a little bit later how to deal with this issue of what we call cold starts. So there's when it has to actually go do this, it's a cold start. Once the Lambda is up and running, it's called warm. When it's a cold start, it can take 2 to 3 seconds. Once it's warm, it's going to execute your code immediately. So here's what AWS Lambda. Here's what the AWS console for Lambda looks like. You have a list of your functions. You go into functions, do a lot of clicking around. Here's what API gateway looks like, and hopefully we'll get to a little bit later. So a simple API architecture on AWS, your client will reach out to your API. Your API will hit API gateway. API gateway will forward your request to Lambda. In this particular case, Lambda is reaching out to Amazon's Dynamo database, getting some data, returning back to Lambda. Lambda is turning back to the API gateway, back to the client. But in many cases, you want to develop an enterprise architecture, and you can develop an enterprise architecture doing this as well. So over here would be an example of enterprise architecture. In the bottom, let's jump all the way to the bottom. Imagine you have a bunch of services. Each one of those little orange things, which is Lambda's icon, represents a Lambda function. And you would have each Lambda be responsible for something else. Maybe you have a user service. Maybe you have whatever services your microservices are. And you would have a bunch of services spun up over there. And then you would create API gateway, which maybe is your RESTful API, that hits a Lambda. Your Lambda says, oh, someone's creating a new user. Let's reach out to our user service. And maybe for your app, you're using SNS, which is Amazon's messaging service. And in that case, you're receiving a new message from your app, and it reaches out to its Lambda and says, oh, this is a new message. Let's go over to our messaging service. And you can develop a really complex enterprise architecture, actually really simple enterprise architecture over here. So frameworks. So you're probably going to want to, if you're going to be serious about serverless, you actually probably want to use a framework. Why frameworks? So in general, by writing your code, and by writing your code, if you're going to have a bunch of functions, typically as you grow on a serverless architecture, you're going to probably have a dozen or more, or maybe even 50, 60 functions. You're going to start writing your code in smaller pieces. You're going to have bigger functions. You're going to have a lot of functions. Creating a new Git repository of all of them is a real pain. Having something that in general running local tests is a real issue. Handling environment variables, deploying to CI server, and then provider agnostic. A good framework is actually going to allow you to simply switch from maybe AWS to Google Cloud, and it's not so simple, but there'll be less changes that you'll have to make on a good framework. And then in general, there's a lot of challenges that are going to come up with the serverless framework. It's definitely newer stuff, and there's a community behind it that will allow you to help solve those other challenges. So we're going to talk about serverless framework. What a name. To come up with a better one. So serverless framework. So we're going to talk about serverless framework because that's what we've been using. And a year ago, there weren't all that many other options, but it is a great framework. It's community-driven. It's a large community, and they have awesome documentation. We're just going to jump over to their site. Here's their site. We can see the documentation is really, really clear. You can just jump around it, and you get everything that you want. And we've been very, very, we've seen it grow from a really small following to quite a large following at this point. Okay, so to get started with serverless, you're going to npm install globally serverless. And I'm just going to use SLS, which is short for serverless. Out of the box, it comes that way. You're going to do SLS create, and you're going to select the template. In our case, we're going to be using Node.js. And we're going to set the path of where it's going to be, of where your folder is. And then you'll go into your code. You'll change around your code, create your function. Then you just do SLS deploy, and it takes care of the rest and deploys it for you to Amazon. So here's the list of some of the templates that are here. Naftali, you here? No? Scala? No? Okay. They recently added Scala. So let's jump into some code. Okay, so over here, basically, I made an application, and I just have a bunch of modules, so we can walk through this quickly. So in this basic folder is when you initialize a new serverless project, it's going to look like. So there's going to be two two files that are really important. Our serverless YAML file and our handlers file. So let's jump to our handler file. And we could see over here, it looks very similar to that Lambda function before. We're sending back a message. And then we'll go to our serverless.yaml file. Before I do that, I'm going to walk through this YAML file, but let's just do SLS deploy. Okay, let's walk through the YAML file. So as we can see, we named our service. We set our provider, AWS. We set the runtime for Node. I have provisioned on my machine multiple AWS profiles. Those are the credentials. I'm just specifying which credentials we're using, so it goes to the right account. We could specify different stages, so it's really good for, in this case, we do development. We could have integration. We can have production. So it's really nice. Helps us with that workflow. We could specify the region. So over here is just some IAM stuff. That's permissioning stuff. A little bit more advanced topic. Okay, so now we're going to look at our functions, and this is really the core of it. So we're going to create a function. So just for anyone that's not familiar with YAML, YAML is a really simple, for me I found it very confusing in the beginning, but YAML it's basically an object with a property. So hello is a property of functions, and then you have lists. So there's multiple events, like an array of events, and you just put a line for each property of an event of a list. So we have hello, which is a function. We tell Lambda what the handler is. So now, we tell serverless where the code is to actually execute this. So we say handler.hello, which is our handler file. Handler is exporting hello, the hello function, and that's what's going to be the code to actually run this. Now we're attaching to this an event, an HTTP event, which means we're attaching an AWS API gateway get method, which is going to be hello, and we're going to be able to invoke our function. So as you can see down here already, we finished deploying our service. It tells us that we've been successful, and it gives us a URL where we could go invoke our Lambda. So let's take that and let's jump over to the browser. I knew I didn't want to do live coding. Oh, okay, it went. I don't know why it took so long, but... Oh, okay, thank you. Okay, so here we go. So for anyone that says go serverless, we got our message back. Yeah, we just deployed our first Lambda function. Very exciting. So that's great that we could execute our code, but how do we actually go ahead and test this locally? So serverless out of the box gives us a command, and that's SLS invoke local -f, which is our function name, and hello. And we'll run that, and it runs locally. So that's cool. We could actually go ahead and test things locally, but it's not really so great for, like, there's so many other things I want to see how it actually works, and running this command is not so great. So one of the really nice things about serverless is that it has this thing called plugins. So we're going to add in a plugin called Serverless Offline. So we do npm install serverless offline, and once we have it installed, we could do SLS offline start. And it tells us on a localhost port 3000 our server is running. So let's go to localhost port 3000 /hello. And here we go. We got our, let me just go ahead and full screen for this. Okay, much better. So now we see it's actually running locally. So that's awesome. Now we could actually start building something. So let's just jump back to our Lambda, and I think this is really worthwhile for everyone to see. I'm going to go with our handler file, and we're going to see what the event actually looks like. Let's see what we have access to. Okay, so I'm not sure how well you can see in the back, but clearly we could see in the event we have access to all of our headers. We have access to our path parameters, request content. If we passed in a query parameter, if we passed a name equals Akiva. we'll get it down over here. Query string parameter name equals Akiva. So now you can actually start thinking about how you can actually start building REST applications. Should be very familiar for anyone that's built a REST application of how you would actually deal with the data and what you would actually do.
Always a GET request?
No. So in our YAML file, we define the method. So since we defined the method, that's basically what we did over here. Okay. So now let's actually move on, and let's actually go ahead and build the REST API. So for the rest of this talk, we're going to use a paradigm. We're going to be pretending that we're building an application where, for a meetup, where it's going to show the from devs meetups that there were. We're able to select on a meetup, see all the people that came, select on a person, see all their meetups that they went to. So let's just think about what we would need in order to do that. So off the bat, I think that we need maybe 2 or 3 RESTful APIs. We need a meetups API to get our meetups, and we need a people API to get our people, and maybe we want to get an individual person so we could get just their information, so we have to be able to pass an ID. So let's go ahead and build that API. So we're going to start with a YAML file, and I got rid of that hello function. And we're going to start with 2 new functions. We're going to add a meetups function and a peoples function. And for the meetups, we're going to specify handlers.meetups. So in our handlers file, we're going to have a function meetups. And for the people function, we're going to have a handler people. And then for each one of them, we're going to create a route. So we're going to make a meetups route, which is a GET request. And we're going to make for people, we're going to make a people route. And if you notice, this event actually has 2 HTTP requests. So the interesting thing is, we could actually add on as many events as we'd like for each function. So this function is going to take care of people when we're just requesting people, or people when we pass an ID. And in the function, it's going to have to be smart enough to actually figure out what the request is. Now, what's really interesting is that for anyone that's used Express or has an Express server running, people have been figured out how to run Express on Lambdas. And what many people have done is they'll just make one function, they'll call it API, and they'll forward all their requests to the Express server, and then they're back to regular writing Express server, and they never have to get involved in any of this type of stuff again. So it's actually really interesting. So at this point, I'm going to SLS deploy. So we'll get access to our new functions in a minute, but since it takes time, we'll actually just walk through what's going on over here. So we'll jump over to our handlers file. In our handlers file, we have 2 functions. We have a meetups function, and we have a peoples function. And we have a third function called response, which is just taking in the status code and what we're getting back from our data and wrapping it into an object. So let's go through our meetups function. So just so it's clear for everyone what's going on over here, we'll start with the meetups function. So let's go through our meetups function. We're going to skip line 16. We'll come back to that in a minute. So what we're starting is we're getting our meetups. That's a call that's actually going out to the database. Get meetups is a function. We built out a full SQL server over here, and we did that so it's not any local data. It's actually reaching out to a real live MySQL server. We have 3 tables. We have a meetups table, a peoples table, and a meetups attendees table, which is the association between the 2. And I don't think there's any point in getting into the nitty-gritty code using SQLize, reaching out, getting our data. So this get meetups function, it reaches out, returns a promise. Once we get it, then we get our meetups back. And when we get our meetups back, we send it back over the wire. And our people function is very similar. We got the person. Actually, let's talk about this. So over here, we need to access. If there's a parameter, we're passing in people /ID number 15. So then we would actually need to get that data. The way we access that data is through events.path parameters. So we take the event.path parameter, assign it to person. Now we call get person, passing in the person ID, etc. Now, if anyone noticed, there's this line 16, that says context.callback waits for event loop, empty event loop equals false. Now this is a really, really interesting thing, and it's a really important thing when you're writing code for Lambda to understand what's going on over here. Sorry about that. So AWS basically says, give me a piece of code. We're going to run it, and we'll run that code, and we'll return to you the result. Now, what happens if you run a piece of code, and your code's running, and you're like, hey, AWS, return it, but you still have other code running in the background doing other stuff? So AWS is a little bit confused. They're like, what should we do? You have this other code running, doing other stuff, but you're telling me you're triggering the callback. So what do we do? So AWS by default says, well, if you have other code running, you're only paying for what you use. I'm only charging you, and we stop charging you once you call your callbacks. So we're actually going to wait until that other code stops running, and then we'll trigger the callback. So my first time I'm dealing with this, hooking up to MySQL Server, and I'm running my code, and it's just not returning. It doesn't make sense, and I'm going crazy until finally I figured out what's going on over here, that if you're using a package that is pooling and creating a bunch of requests, apparently there's some stuff still in your event loop that is never going to go away, and your function is never going to return. So if you're doing any sort of asynchronous JavaScript, you're probably going to find yourself most times you're going to end up needing to do that context.callback waits for event loop equals false. We actually had a really interesting case with this when, just in short, when someone would post a post, we had a Slack function that we were notifying ourselves that, hey, someone just posted a post, and we didn't care to return that. We didn't care to wait for that to resolve before we sent the finished API call. Well, it turns out that what was happening was we were getting the notification of the previous post, which is a really crazy, bizarre thing. So these are very interesting things that you have to keep in mind when you're actually programming in Lambda. So let's jump to our API. It's resolved. We got back our data over here. We got back our APIs. Let's go over to the browser. We're on. Sure. Oh, perfect. Okay, thanks. Okay, so too big? Good. Okay. So basically, here's a list of. I wish this would minimize by itself, but here's a list of meetups. So we have our Let's Build Our Own Observable, Performance Matters, GraphQL and Serverless app. Again, folks, the next meetup is Morty's giving it on Tesla and autonomous driving. Okay, so very, very simple. So I actually want to do auto watch. When we hit it for the first time, this API call took about 2 seconds. And we're going to hit our people route. And I want you to just watch the browser. People. One, two, three. Okay, so it took about 3 seconds. Okay, so we grabbed a bunch of data by people. We didn't know your phone number, your avatar, and your profession, so everyone got assigned some crazy thing. These are the first 30 people that said they're attending the meetup. So Naftali's actually the helper. Okay. Okay, so that's really interesting. We just saw it took about 2 seconds. Let's run it again, and it went instantly. So clearly we see this cold invocation issue that when we hit it for the first time, it takes about 2 seconds, 2, 3, 4 seconds. I know we've seen it take up to 5 seconds sometimes. So this is a real issue that actually has to be addressed. So we built our API, we built our REST API, we're ready to roll. We can actually go build our application, but we need to take care of this issue before you can move ahead. So another serverless plugin to the rescue, and it's called Serverless Plugin Warmup. And all you have to do is npm install serverless plugin warmup, add it to your list of plugins, and go to each function and select warmup is true. You deploy, and you're good to go. You have nothing to worry about.
How are they doing that? What does it cost you?
Yeah, so okay, I'm going to try moving quickly because we want to get the GraphQL also. Okay, so basically, I made a calculation today. It's 20 invocations an hour. Do all the math. So basically, if you're using the smaller memory functions, it costs you about 8 cents a year. If you're using the higher memory functions, it costs you about 83 cents a year. So, okay, yeah. So under the hood, basically, and that's what I actually want to what I want to jump to is let's just quickly see what it looks like in Lambda. So in Lambda, basically, here's our functions. When we deploy the serverless function, the warmup function, there'll be another function which is actually using AWS timing service, and it calls your function every 5 minutes. It invokes it, and once it invokes it, you're good to go, and it basically will stay warm.
Let's say it's a function that's a write function.
That's a write function.
You're posting something.
Okay, great. So basically, I didn't want to get to that, but just to answer your question, basically you would go to, and what Chai is asking basically is, you don't want to invoke your function every single time in order just to keep it warm. So what you would do is, I'm sorry, my handlers, and as you can see in this case, I already broke my handlers into a folder where it's much easier architecture to clean it up. But basically, you would put this line of code in the beginning, and it just says, if I've been invoked by the warm-up plugin, then just ignore me. Okay.
What about concurrent requests?
Okay, so just in a, because we have a whole GraphQL piece. So I just want to mention one other thing, and then we're going to move on to GraphQL. And I'll be happy to take anyone's questions afterwards. So basically, there's another package called that you're going to want to put in a Webpack package, and you're going to want to do this for multiple reasons. And A is you're going to want to write a little bit more modern JavaScript than Node 6.10. But besides that is that as you grow your Lambda functions, right now when you're zipping them up, it's creating one zip file, and every function technically has the code from your entire project. And as you're going to grow, as you're going to have more node modules, it's going to be a really big issue because eventually, first thing is your code is not going to run as quickly and execute as quickly. But the bigger issue is that you're going to, AWS gives you a maximum amount of size that you're able to upload in your zip files, and basically you're going to exceed that. So you want to implement this Lambda, this Webpack thing. It makes it really easy to do. It goes through your code, and it says, okay, what node module is using for each function, does tree shaking, and sets up, and you're good to go. So in short, that's it for the serverless part of the talk. And now we're going to hand it off to Tzvi for GraphQL.
Sorry, give me 1 second here. Why isn't it? It's not working properly. Access speaker nuts.
It's a 13-inch screen.
Yeah, but it's not extending properly. I can't figure out how to do it.
Oh, there it is.
No, I can't find my mouse. Oh, there it is. I'll find it eventually. There it is. Alrighty. Sorry about that. Just give me 1 second here. Can we turn on the music? No, I don't want it. I don't want to mirror this one. I keep losing my mouse. Alrighty. Looks about right. Alrighty, so Akiva built the serverless GraphQL, sorry, the serverless REST API. Does this thing work? Oh, here we go. And he built us a meetup endpoint and a people's endpoint to build this hypothetical application. So we have our people endpoint here. I'm running a localhost because I don't have his serverless thing, and there's the meetup endpoint. So let's say we're building an application where we were getting the people and we're getting the meetups that they were in, and of the meetups that we were in, we're trying to just get the topic. Sure. What's the shortcut?
Control.
That didn't work.
You gotta be focused on
Zoom. Click on
Alrighty. Okay. So yeah, in our hypothetical application, we're going to have people, and then we're going to display their meetups. So in a normal REST API, we'd go out, we'd get the people, we'd go hit the meetup endpoint, we'd get the meetups, find the people that are in there, and get that information over there. But what if instead of having to reach out to two endpoints, going back and getting the data, we could just write a simple query. I'm in the wrong one here. Focusing. We can just go ahead. This isn't working. Oh, I'm in the wrong thing. That's a good reason. We can just go ahead, write a simple query, ask for the data that we need from a single endpoint, and then we get that data in response. So over here we just have a query. We query the people. We pass an ID, and we just ask for the ID, the first name, the last name, the avatar, their meetups, the topic of that meetup, and we get back the data in a JavaScript object. And there it is. One single query, one endpoint. That's all it is.
We're done.
Huh?
We're done.
Yeah, we're done. I promise no intro. So we're just talking about some of the pain points that you see in RESTful APIs. So apps receive way more data than they actually need. So let's say we queried the person ID of 27, which I think is Morty. And we really only wanted the first name and the last name. We're still going to get back everything that's supposed to be returned, so we get all this other stuff. And Morty's a mechanic now. The server doesn't know what data the client actually needs. This really follows the first point. It just sends back whatever the server is supposed to send back. You can't define what type of data you need. It's hard to maintain because if you want to extend that, you have to have multiple endpoints, or you'll have query parameters. We've all seen things like this, where you just start passing on all kinds of things, and it gets becomes very difficult to maintain. And documentation, even if you use something like Swagger, you have to keep your API in sync with your documentation in sync with your API. It's also a real pain in the neck. So welcome to GraphQL. With GraphQL, the client tells the server what it wants. You write a query, you get the data that you requested, nothing more, nothing less. The client defines the structure of the data, not the server. The data that the client defines that is required, that's the way the data is returned, in the same shape, the same way it was requested. GraphQL is built around the schema, which is just like basically a contract between the client and the server, and just describing the data. It's strongly typed, which makes it self-documenting because it's strongly typed. I'm just going to jump into the history of GraphQL a little bit. GraphQL stands for Graph Query Language. Should not be confused with the graph database. Has nothing to do with it. You can take the word query maybe and think of it sort of a SQL-free API. You have a single API endpoint. You don't have multiple endpoints. And you're basically just querying your API and getting the data that you need. It was created by Facebook in 2012. They open sourced in 2015. It officially became stable in October 2016. We started using it about a year ago. It's come a long way since then. There was not too much documentation. Only a few people were using it. Now it seems like it's all the rage, although apparently not from when Akiva asked how many people are using GraphQL, but whatever. A lot of people are using it outside of here. GitHub, Twitter, Facebook. Twitter in their new mobile clients are using GraphQL to do, I don't know, tens of millions of calls a day, and they're transitioning. I think they're going to do it for all their calls and mobile clients. GitHub built version 4 of their API entirely in GraphQL, and you can actually play around with it at developer.github.com, and it hits their production API. You can do really cool things with it. So what is GraphQL? GraphQL is similar to REST in that it's a specification, not a tool. I know REST is not really a spec, it's an architecture, but we're going to call it a spec anyways. It's language and platform agnostic. It doesn't really care what the client is, what the server is, if it's really a server to a server and you want to call it a client to a server. It doesn't really care. Doesn't matter on the language. Pretty much any language and platform will work. There are client and server libraries in pretty much every single language. And we made another Tully joke. Is he here? We're going to have to do this all again. I'm just going to jump into our data model here for a second. So it's just a graph. And if I can get my mouse here. Can everyone see this? Or should I zoom it in? OK, how's this? So you can just see the relationship here between everything. So we have our query, we have our meetups entry, and our people. Oh, this was generated by just running, it's called an introspection query. Basically, because there are types, you just run a query that returns all the types, and it generates this in a second. I didn't have to do anything. There was no cool magic. I mean, there was cool magic that happened, but nothing that I did. So there are two entry points. There's meetups and people, and you can see the relationship that meetups has this meetup type, and the meetup type actually has this people type, which relates to here, and the people have their meetups, and it all goes back and forth. Where's my mouse? Alrighty. So how does it all work? So on a very basic level, sorry about that. So you have a query, which usually happens from a client that gets normally passed through a GraphQL client. That gets passed off to a GraphQL server, and this is sort of the middle point between the front end and the back end. The GraphQL server will pass it off to a resolver, which we'll get into detail about all these things in a minute. And the resolver goes ahead and resolves the data by getting the data from the various backends. We'll jump into all that. That's fine. We're good. Oh, on this? Oh, very cool. Alrighty, so there are three operation types of GraphQL. There are queries, mutations, and subscriptions. So until now, we only demonstrated queries. That's why we always had query written. And we'll talk about all of them now. Queries are the read in create, update, and delete. So just simply demonstrated here, you'll see there's, can't zoom in, so tough luck. So we have the query, which is the operation type. This is our entry point of people. We have people and meetups. The ID that we're passing in is an arg. Is just an argument over here. This is person ID 23. We're requesting a first name, a last name, profession, and under people we're requesting the meetups type, and we're just requesting the topic from there. I'll actually run this in here. I can't even see it, so forget it. No, I can change it actually to, but I forgot it. Takes too long. GraphQL mutations. Mutations are the create, update, and delete parts of CRUD. So with mutation, you could think of it basically as a post request. Pretty much all those things. In this mutation specifically, so we have our operation type again, and this type is called star meetup. So meetups here have stars. I think Morty's upcoming meetup has the most stars. And we're passing an argument here of 2, and the meetup with the ID of 2 is going to get triggered, and it's going to return a query of topic ID and how many of the topic, the ID of it, and how many stars it has. And what this will do is it will just add a star every time. I'm actually going to show this. Just bear with me for a second. I'm just going to change the color. 2. I know, I'm just trying to think how to do it. I'm sorry? All right, whatever. Yeah, so here we have like, I'm just going to jump back to queries for a second. So we query the people, and we get all the IDs. And if we just want, you can see it's really quick because it's also hitting that the same MySQL database. And let's say we want last name. Let me get those back also, and those other kind of stuff. I'm actually going to get meetups just to show you that when you have the stars.
Get your work.
Maybe we'll talk about that after. So we could see that they have. Alrighty. So meetup ID of 2 has 6 stars because we keep hitting that mutation over there. Alrighty. GraphQL subscriptions are a way to get notified in real time about changes to your data. It works over WebSockets, and it's a great way to build real-time apps like chat apps or comments in a blog post or something like that. I'm primarily going to talk about queries and mutations, not subscriptions, basically because I never work with them, so I don't really know what I'm talking about. So GraphQL has a server and a client. GraphQL Server is what I'm talking about first. So every GraphQL server has 2 core parts. There's the schema, which you mentioned earlier, which is basically just a data model, and resolve functions. So resolve functions, or also called resolvers, specify how each type, and we said like meetup was a type and people was a type, and every field in the schema is connected to the various backends. So you could have on an individual field, you can have it resolve one to MongoDB and another one to a Postgres database and another one to MySQL database, another one to a REST API, another one to another GraphQL server, and you can just go crazy and do whatever you want. It doesn't really care. Just a little bit of how a query and a mutation actually resolve. So it gets parsed. It just checks for syntax errors, it gets validated against the schema, and it executes. So it actually cascades down the query tree. It puts the data together, shapes it, and returns. What's really interesting is that as it cascades down, if you return a promise, it will wait for that and then continue down. So I'm just going to jump into some of the code that goes into the GraphQL server. It's really pretty simple. So this is the GraphQL server that we're actually running here, and I'll just go through it and break it down a little bit. So on a very basic level, this is a GraphQL server. We're using something called GraphQL Tools, which is a package from Apollo. We're using some server package that works in Lambda. You have type definitions. You have resolvers. You take the type definitions and resolvers, you stitch them together, and you export them, and there's your GraphQL server. So type definitions, we have here, we have, well, really, we have 2 types. We have the meetup type. It has a date. Can everyone see this? At least. So you have a date, which has, and it's again, we said it was strongly typed. That's a string, and it's required, meaning that the entire meetup's type won't resolve unless there is a date. Otherwise, it'll just error out. As an ID, which is integer, location, topic, people, which resolves to the people type, which is over here. And people type is pretty similar. It's got all these types defined here. So this is basically just describing the data. And then type query just means the root query, because again, there's only one endpoint. So think of this as your endpoint. And then you have the meetups and people, which are your entry points into your data. These are just arguments here, and it returns the meetup type. And then your resolver for your query will just resolve meetups to get meetups, which is a function that Akiva mentioned earlier and built out that goes out to SQLize and gets it from MySQL and does this thing. So just back again to the code that's actually running on the server, it's pretty similar. These are our functions that actually go out and get the data. These funny things here are actually comments that can go and even though it's self-documenting, you can actually describe some of the fields. I can see it in GraphQL. Which one is it? It's under stars. I'm going to skip here. And yeah, meetups and stars. Here's some people. So you can see over here the list of people that attended this meetup. That's the same code that we see over here, just describing it. So that's the documentation that's all built in, and you can just describe it over there. What else is here that we don't have there? Here we're just passing in arguments that can actually query specific people. And yeah, that's basically your whole GraphQL server. There's really not much there. Just jumping over to the GraphQL client. So there are 2 main clients, I think. I haven't really done too much research into it in a while. We're using Apollo client. There's also Relay from Facebook. It doesn't seem like it's all that popular, much like Flux versus Redux, where the tool from Facebook didn't seem to win. Apollo is by the Meteor team, and they do a lot of really cool stuff in general around GraphQL on both the server and the client. So what actually is a graphical client? Why do I need one? So technically, you don't need a client, and you could just use HTTP fetch and make a post request and just stick it into JSON and fire off your query, and you're good to go. But you might need things like error handling. You want to have middleware and afterware. You want to, authentication, dealing with network issues and retrying the network. And for things like GraphQL subscriptions, you have to have a network client because it works over WebSockets and does a lot of interesting things with the network. GraphQL Client also gives you a cache. And one of the things, it does two main things. And one of the interesting things that it does is that it keeps your UI consistent across queries. So what that means is, let's say you had two fields side by side that were requesting all the people. And there were only two people in your database. And you had a little reload button under each one. And you added another person, and you click reload by the first one, so the third person will come up. But then the other one won't update because it has no idea that there's new data. But when you have a central cache, then everything updates in real time because it's just reading the data from the cache. And you don't have to go and make another query. And then if you have that across your application, even across other pages, it's very interesting.
Even from separate queries? Or they have to be the same queries, have to be the same?
Well, if it's the same query type, there are actually, I think, ways to do it. But effectively, no. And this is all in the client, yeah. So let's say you request a title. Let's say you have a product page, and you're just showing the title on the home page. When you go into the product page, it's not going to it doesn't need to fetch a title again because it already has it. And then that's really the second point, that you don't have to go about fetching a bunch of things again and again and again because you have it in your cache.
How does it invalidate the cache?
How does it validate the cache? Well, it reads the schema and it sees if it's there, and assuming there are IDs.
How does it invalidate the cache?
I'm not sure what you mean exactly by invalidate cache.
Bust the cache. How does it?
Why does it need to bust the cache?
Oh,
It cleans it up. It does its own thing, cleaning it up. But I'm not sure how it works under that. I don't know. So just talk about tooling for a minute. So there's this thing called Graphical, which is built into the GraphQL spec, which is basically like an IDE for GraphQL. This is actually pretty much Graphical right here. It used to be that when we started, GraphQL had to be built as middleware in your API, and it was really, really, really annoying to implement. But now there are a lot of tools that can do this. It's called GraphQL Playground. It's by the GraphQL team, which we'll talk about in a minute also. But basically, I know it's a little hard to see here, but it has really cool auto-completion, like Shai mentioned earlier. But you can just do option and space, and let's say you have a query, and it will literally pull the fields from the schema. So, and then it will show you there's date, and let's get one more topic, and you can just execute it, and you're good to go. It's really powerful, especially if you're just playing around with an API or you're trying to figure out how certain fields resolve. And then they also give you the schema. It's all detailed over here of the queries and the mutations, the mutation types, and all the documentation is right there. Just some of the advanced stuff. You can do persistent queries with Apollo Engine. So basically, Apollo Engine is a tool by the Apollo team, which built the Apollo client. And if you keep hitting your server with the same types of queries over and over again, they can cache them and do interesting things. There's the N+1 issue. So let's say you request, actually we can try it out because I'm not up to 20 minutes yet. If you don't include my break in the beginning. Let's say we requested people, which is the other type. Just get the IDs. And then we get meetups. Again. Get the IDs. And then get people. Get the IDs again. And
Sure you want to run it?
yeah, actually, for fun, you can run. I can show you I can show it running.
We're in AWS.
No,
Locally.
on my machine. I have no access to it, but all right, either way, I'll run it. It's going to take a little while. But you can see it's just slamming the database going around. Oh, that was pretty quick. But okay, it's local, so it doesn't really count. But imagine you had, I don't know, you had a whole bunch of people. You can easily run into hundreds or even thousands of queries because it's very nice that it can query basically nested fields, but every single one's making a separate call, and you run into very interesting issues. So there are two ways that I think off the bat that you can deal with this. One of them is Facebook has a package called Data Loader, which basically just batches the queries and does things like that. And Akiva actually came up with a way, you got a little crafty with Sequelize, where you do enough joins early enough, and it has all the data and it resolves automatically. It resolves before it can actually run into that issue. For the details, stick around after. I'm sorry?
So if you're returning enough data at the start, you may as well just go with that. You know, not.
Okay, no, that's valid, but assuming you built your entire, yeah, but then you can't go, then you'd have to go ahead and hit multiple APIs. The whole point of GraphQL is that, let's say from the client perspective, depends why you're using it, but yeah, that's true. It's not the silver bullet. I'm missing my slide deck again. Just talk about some tools. This is a little cut off on the top. But there's a great tutorial site called howtograpql.com, which is pretty new, but all the other sites point to it, even the Facebook GraphQL site. And they have really, really good tutorials if you want to get a little more involved. No, it's like everybody. But the people behind GraphQL, I think, are the ones that started. It's a mix of the guys from GraphQL and Apollo and whatever. I'm losing my thing here. Another really cool service to check out is called GraphQL, graph.cool. We found them like 6 to 8 months ago. It was a little early. Maybe if we started something now, we would try it. But they basically built the GraphQL backend as a service. And it seems really, really cool. I can't say I've ever actually played around with it and tried it. But it seems like a lot of people are using it. And the team behind it has built some really, really cool tools. Chromeless is actually built by the GraphQL team. They built the GraphQL Playground, which I was using before as my IDE for GraphQL. They're doing a lot of really cool things. Prisma is just a tool you can use to wrap an existing REST API, although there are other ways you can do that also. GraphQLbin.com is another thing you can check out. That's just graphical online. You could just query if you happen to know of a GraphQL API online that you can actually query. Yeah. Oh, I forgot to show that. You could also check out the Apollo docs are really, really good, and you could check out GitHub's public GraphQL API at developer.github.com. That's it.